Aston Martin may have just gained the most valuable advantage in Formula One: time. Reports dated July 22nd and July 26, 2026, claim Honda's new power unit reached an important sign-off milestone earlier than expected. But there is one massive detail the headline does not prove. Honda has not confirmed an early engine debut in the available source. No official debut date, no public performance figures, no testing schedule, and no direct statement explaining exactly what was approved. That means this story could be even more important than it first appears. Because if Honda has genuinely completed a crucial development stage early, Aston Martin could gain extra time to test reliability, improve cooling, refine energy delivery, and design the car around a clearer power unit package. But early approval is not the same as an early debut. And the difference between those two claims could completely change what Aston Martin's rivals should fear. Subscribe to the channel. To understand why this distinction matters, you have to separate two moments that sound similar but mean completely different things. Signing off a power unit is one moment. Debuting that power unit is another. An early sign-off can mean that an important stage of development has been approved. It can give engineers more confidence in the direction of the project. It can reduce uncertainty, open the door to more detailed testing, and allow the chassis team to work around a clearer set of requirements. But an early debut would mean something much bigger. It would mean the power unit is ready to appear in a running program earlier than originally expected. That could involve a test environment, a complete car integration program, or another form of public or private running. The available source does not confirm any of that. It does not provide a debut date. It does not identify a test. It does not explain whether a complete power unit has already been installed inside an Aston Martin chassis. And it does not include a direct Honda statement confirming an early track appearance. That missing difference is crucial. Because Formula One development is full of milestones that happen long before the public sees anything. A component can be approved. A design can be frozen. A specification can be accepted. A test program can move forward. None of those steps automatically means the finished package is ready to run earlier than planned. Think of building a new aircraft. The engine design may be approved. The major systems may pass internal reviews. The engineers may feel confident enough to continue. But that does not mean the aircraft is ready to take off the next morning. The engine still has to work with everything around it. Cooling, electrical systems, structural loads, software, fuel systems, and the behavior of the complete machine under real conditions. A Formula One power unit faces the same challenge. Honda may develop a strong system on its own. Aston Martin may design an aggressive chassis. But the real test comes when both become one car. That is where hidden problems can appear. A cooling target that looked manageable may become more difficult inside tight bodywork. A vibration that seemed harmless may affect another component. A weight estimate may influence the balance of the car. The way electrical energy is delivered may change how the driver controls traction. One small issue can spread across the entire package. And that is why the word debut carries so much weight. A debut suggests the project has moved beyond isolated development and into a more complete stage. The power unit is no longer only being understood as an engine. It is being understood as part of the car. That would be a major moment for Aston Martin. But right now, the attached information only supports the claim of an early sign-off, not an early debut. And that means the real story is about opportunity, not proof. Aston Martin may have more time. It may have greater certainty. It may be able to make earlier decisions. But none of that guarantees the car will run sooner. Still, opportunity matters enormously in Formula One. Every additional day can become another chance to find a weakness. Another chance to improve reliability. Another chance to reduce unnecessary weight. Another chance to refine cooling. Another chance to understand how the power should arrive when the driver leaves a corner. And this is where early progress can quietly become performance. not through one dramatic breakthrough, through hundreds of smaller decisions made with better information. Imagine two teams preparing for the same race. One team knows exactly how its major systems will fit together. The other is still leaving room for several possibilities. The first team can commit. The second team must protect itself. It leaves extra space. It delays certain decisions. It prepares backup options. Those precautions may be necessary, but they also cost time and freedom. That is the possible advantage Aston Martin could gain from an early sign-off. The team may be able to stop designing around uncertainty. It can begin designing around something more specific. That helps the aerodynamic department. It helps the cooling group. It helps the chassis engineers. It helps the people working on software and energy deployment. And it helps the manufacturing teams understand what must be built. But here is where the pressure increases. The moment an important system is approved early, the rest of the project is expected to respond. People begin asking whether the chassis can now move faster, whether testing can begin earlier, whether the car can be assembled sooner, whether Aston Martin has found a way to get ahead of its rivals. That expectation can become dangerous, because development does not always move evenly. One department may be ahead. Another may still be solving a difficult problem. Honda may reach an internal milestone early, while Aston Martin continues working through chassis or packaging challenges. The entire project can only move as quickly as the slowest critical area. That is why early engine progress does not automatically move the whole car forward. It creates an opportunity for the rest of the program to accelerate. It does not force that acceleration to happen. And this is where the phrase "changes everything" needs to be tested carefully. What exactly changes? The development timeline may become more flexible. The engineering teams may gain more certainty. The integration process may begin with fewer unknowns. But the competitive order does not change because of a milestone alone. The stopwatch does not reward early approval. It rewards the final package. That package must be fast, reliable, efficient, and easy enough for the driver to use at the limit. Aston Martin still has to achieve all of that. Honda still has to prove that the power unit can survive repeated stress. The cooling system must work in difficult conditions. The electrical side must deliver energy consistently. The engine must perform across an entire race distance. And the car must carry all of this without giving away too much aerodynamic performance. That is the difficult balance. More cooling can protect reliability, but more cooling can create larger openings. Larger openings can disturb the airflow. Disturbed airflow can reduce downforce or efficiency. So the team may gain security in one area while losing speed in another. This is the hidden battle behind every power unit program. The strongest engine on paper is not always part of the fastest car. The fastest car is the one that uses every major system without paying too much somewhere else. And that is why Aston Martin's work with Honda has to be deeply connected. The power unit cannot be treated as a separate object. The chassis cannot be designed first, then adjusted later. Both sides have to understand the compromises from the beginning. How much space is required? How much heat must be removed? Where can the weight be placed? How tightly can the rear bodywork be shaped? How should the power arrive to protect the rear tires? Those decisions shape the personality of the car. A smooth delivery can help the driver apply power earlier. A difficult delivery can create wheel spin, hesitation, and tire damage. A compact layout can help aerodynamic performance. A layout that is too tight can create cooling or reliability problems. Every gain sits beside a risk. And this is where extra time becomes valuable. Time allows engineers to test more than one answer. They can compare solutions. They can reject weak ideas before those ideas become expensive. They can discover whether an aggressive concept is truly better or only looks better in simulation. That is where early progress can make a real difference. Not because it creates certainty about success, because it creates more chances to avoid failure. But Aston Martin must be careful. An early sign-off can also lock the project into a direction. Once major systems are approved, other parts begin adapting around them. Designs become connected. Manufacturing begins. Changing course later becomes more expensive. So the benefit only exists if the approved direction is the right one. Speeding through the wrong decision would be worse than reaching the correct decision later. That is the uncomfortable truth. Finishing early sounds powerful. Finishing correctly is what matters. The attached source does not provide enough information to judge the quality of the signed-off design. There are no public performance figures in the material. No confirmed reliability data. No details about cooling demands. No explanation of energy deployment. And no proof that the complete package is ready for an early debut. So the milestone should be treated as a positive signal, not a final verdict. But positive signals can still change how a team works. Confidence spreads. Departments become more willing to commit. The factory can organize around a clearer timeline. Engineers can focus less on protecting against unknowns and more on improving the known package. That psychological effect matters. A project surrounded by doubt becomes cautious. A project with clear progress can become more ambitious. People make decisions faster. Communication improves. The organization begins to believe the target is reachable. But confidence creates another risk. Overconfidence. Aston Martin cannot allow an early milestone to become a reason for rushing the next stage. Testing still has to expose the weaknesses. Engineers still have to question the design. The project still has to survive failure before it can survive racing. That is why the next phase matters more than the sign-off itself. Can Honda repeat the same performance under different conditions? Can Aston Martin integrate the power unit without creating a major compromise? Can both sides solve problems before those problems reach the track? And can the complete car operate at its limit without being forced to protect itself? Those are the questions that will determine whether this development changes everything. Because the biggest advantage may not be an earlier debut. It may be the chance to arrive at the planned debut better prepared than anyone expected. That difference sounds small. It is not. An early appearance creates attention. A stronger first appearance creates fear. And Aston Martin's rivals will not care when the engine was signed off if the final car arrives fast, reliable, and ready to improve. That is the real opportunity hidden inside this story. Not proof that Honda is already ahead. Not proof that Aston Martin has jumped the field. But the possibility that one crucial piece of the project became clear early enough for the entire team to use time as a competitive weapon. And if Aston Martin uses that time correctly, the first real surprise may not be when the Honda engine appears. It may be how complete it looks when it finally does. And this is where Aston Martin's real challenge becomes impossible to hide. Because gaining time is only useful if the team knows exactly where to spend it. One extra week can be wasted. One early milestone can become meaningless. And one wrong decision can erase the advantage before the car ever reaches the circuit. That is why the next stage is not about speed alone. It is about discipline. Honda and Aston Martin now have to decide which problems deserve attention first. Reliability, cooling, energy deployment, packaging, weight, drivability. Every one of those areas matters. But they do not all matter in the same way. A small weakness in one area may be manageable. A hidden weakness in another can destroy the entire package. That is the danger. A power unit can look strong in controlled testing. Then, one temperature problem appears. The team opens the bodywork to release more heat. The aerodynamic performance drops. The car loses efficiency. The tires begin working harder. And suddenly, a problem that started inside the engine changes the behavior of the whole car. That is how Formula One development punishes mistakes.